applications in right-angled triangles. The question here would be to solve this triangle completely. This means that you need to determine all unknown angles and side lengths of the triangle. Let's start by calculating angle alpha first, as it is the easiest. Because I'm working in a right-angled triangle, I can say that cos alpha equals the adjacent side divided by the hypotenuse. We can put down that cos of alpha equals the ratio of 12 over 13. Using my calculator, I can calculate a value for alpha using second function cos, which gives me 22,6 degrees rounded off to 1 decimal place. Therefore, we have now found the first angle in this triangle, angle C, and it is 22,6 degrees. Angle A is very easy to find, as we already know two of the three angles in the triangle. So angle A would be 180 degrees minus 90 degrees minus 22,6 degrees, giving me a value of 67,4 degrees. To find the length of side AB, we have two options. The first is using Pythagoras. But while we are busy with trig functions, let's rather use trig functions to do this. We know the value of alpha, namely 22,6 degrees, and in terms of alpha, AB is the opposite side. I can therefore say that sine of alpha equals the opposite side AB divided by the hypotenuse of 13 degrees. This means therefore that AB equals 13 times sine alpha, or 13 times sine of 22,6 degrees. When I simplify this using my calculator, I get 4,99, which gives me a length of approximately 5 units, or eenhede in Afrikaans. If you test this answer using Pythagoras, you will also get an answer of 5 units. Here is another triangle for us to solve. Let's start with angle alpha. In terms of angle alpha, the opposite and the hypotenuse are known sides. We can now state that the sine of alpha is equal to the opposite side over the adjacent side, and to determine alpha we use second function sine of 1,5 over 2,1 on our calculator, which gives me, rounded off to 1 decimal place, a value of 45,6 degrees. In this triangle, angle B is therefore 45,6 degrees. Angle A can be calculated by using the sum of the angles of a triangle. These add up to 180 degrees minus 90 minus 45,6 degrees, and this gives me 44,4 degrees. Only side BC remains to be calculated. BC, in terms of alpha, which we've already worked out, is the adjacent side, and we will therefore use the cos function. Cos of B is the adjacent side BC divided by the hypotenuse, which is 2,1. BC is therefore 2,1 times cos angle B, which is 45,6 degrees, and this gives us a length of 1,5 units. In the last example of solving a triangle, we start off by checking what's been given to us. For angle alpha, we have values for the adjacent and the opposite sides. Tan of alpha is therefore the opposite side over the adjacent side. Now we calculate alpha on our calculators by using second function tan of this fraction, which gives us 24,3 degrees. In this sketch, the size of angle A is therefore 24,3 degrees. We calculate angle C by working with the internal angles of a triangle. 180 degrees minus 90 degrees minus 24,3 degrees gives us 65,7 degrees. The last unknown quantity in this triangle is the length of AC. We can calculate AC by using sine of alpha, which is opposite side 4,2 over the hypotenuse, which is AC. And this gives us AC is equal to 4,2 divided by the sine of 24,3 degrees. And simplified, this gives us 10,2 units. There is an alternative method, so let's look at that. We can use cos to calculate AC as well. Cos of alpha is equal to 9,3 divided by AC, which gives us AC equaling 9,3 divided by cos of 24,3 degrees. And this simplifies using our calculator to 10,2 units. There is of course a third alternative, which is to use Pythagoras to calculate AC. You can now go and do this on your own and check if you also get AC to be 10,2 units.